Hi, welcome everyone. I'll be waiting a couple of minutes for more people to join. Okay, welcome. I'll be talking about hat model replacement in Meteor. It is a new feature coming in Meteor 2. It's currently in beta. And I'll be discussing what it is, how it will help us to develop faster, and how it compares to hat code push. A little bit about me. My name is Micaiah Nissen. I am Zodern on GitHub and the Meteor forums. For the past few years, I've maintained Meteor Up, a tool for deploying Meteor node apps to servers. And I'm also the owner of Monte APM, a service for monitoring Meteor apps in production to help improve performance, fix errors, or any other issues in the apps. So hat model replacement helps to improve our developer experience as we iterate on our app. And it does this by updating the app as it's running. It could be running the web browser or the server or in a Cordova app. but it's able to apply changes you make without requiring it to be restarted or reloaded. It works on individual modules within the app. In our Meteor apps, we might have JavaScript files or other types of files such as Svelte or Vue that are then compiled into common JS modules that are then imported in our app and ran. So app module replacement is able to replace those individual modules or add new modules to our app. It's only enabled in development. JavaScript and some languages was not designed to update running code, so it's not completely reliable. There are sometimes issues with it, but it works good enough for development, but we would not want our end users to get into odd state or have the app broken when you release an update. App module replacement is fairly common in JS bundlers. If you use Webpack, Vercel, Vite, or other bundlers, you probably have experienced it. This is a video of it in action. On the left is a simple React app that I'm modifying and saving changes to. And you see the app running within the web browser on the right. So as I make changes to it, the website is updated without reloading. And you see that the counter keeps increasing. It's not affecting that, it's preserving its state. So we already have had code push in Meteor. It's a little bit different in how it works with the web browser and how it works with updating Cordova apps. So I'll be focusing on the web browser. It's unique and it's enabled in both development and production. We get the improved experience while working their app, and our end users also get the improved experience with it, reducing the disruption on them when there's an update. Because it's used in production, it has to be reliable. We can't afford our app to end up in a broken state when we release an update. It's able to apply some changes without redoing the page, like CSS. It's limited in what can be applied this way, but it's nice when it happens. It's able to preserve some state using the reload package. Some packages use this to preserve any values in forms. So if there's an update, our users do not lose what they've entered. The session package and reactive dictionaries are also able to preserve the contents during an update. But since it has to be reliable, it doesn't preserve too much state, since it could break in the new version. Now, if there's a way to automate preserving state within UI components, many bundlers probably would prefer this option because it could be more reliable than mod replacement. But so far, no one's found a way to do that. And it runs at the very end of the build after the server is restarted. So you have to wait a while for app gets large. So why do you want mod replacement? What are the benefits? So here's a rough timeline of what happens when you make a change to your app and Meteor rebuilds. It's missing tons of stuff, but at high levels is kind of what happens. The first four are during the actual rebuild. It takes the files in our app, compiles them, creates the final output, and writes it to disk. Then if it's a full rebuild, the server is restarted, and then the client is updated if necessary. So this whole process can take a few seconds depending on how complex your app is. And you wait to the very end of it before you can try our changes. But with mod replacement, we have everything we need to update the app long before this completes. There's a point where we know what modules will be in the app and where the final content is. And that point is here at the beginning of the link stage. So here we can already know what changed and send it to the app and update it. Now, many apps now will import UI components on both the client and the server import on the server for server-side rendering. In development, we might not care about server-side rendering, but Meteor still has to restart the server. And with that code push, we have to wait for that to happen before trying our changes. But with HMR, we update the app before the server restarts, so you no longer have to wait for that before trying our client changes. Two other benefits is it also avoids reloading the page, and it can preserve more state. You might have external resources or subscriptions that will be loaded when the page is reloaded. But with HMR, we can skip that. The page is already loaded. It's also able to preserve state. You might be working in a multi-step process or in a form or model dialog, which would have to manually take actions to get back to where we can test our changes whenever the page is reloaded. But with hat module replacement, we can preserve some of the state. We can keep the dialog open, preserve some value in the form, etc., to save us time. So in Meteor, there's two main parts of the implementation. We have a new hat module replacement package. This handles updating the app when there's a change. Once the app or one of its dependencies use this package, Meteor will start the HMR server. The HMR server provides a WebSocket server that the app connects to receive updates, and also handles various other functionality needed for HMR. So at the moment, HMR is only enabled for app code and the modern web architecture. I kept it limited initially to simplify development and testing, but soon you'll also have it for the legacy web architecture, for the web architecture for Cordova apps, and for packages. So at a high level, how HMR works is very simple. During a build, we compare the current build with the previous build to see what has changed. We then immediately send those changes to the app, even though the build is still in progress. Now, in Meteor, when it happens, we call it an eager update. Then the client applies the changes. After the build is finished, hat code push is used to apply any other changes that cannot be applied with hat module replacement. For example, if you change the main module or you modify an asset, then we use hat code push. So how are we actually able to update a running application? With the existing code already is run, and in JavaScript, we can't unrun code. It might have made modifications to, might have created DOM elements, set up timers, have connections, maybe created event listeners. So all those need to be undone so it will no longer have an effect on the application. After it's cleaned up, we then will run the new version of the module. And this will then recreate any listeners, DOM elements, etc., using the modifications you made. But not all modules can automatically be replaced. They have to be able to be properly cleaned up. So we have to have a way for modules to opt into receiving updates. And in HMR, there's a updates bubble up. So if you modify a module that does not accept updates, we then will look at the modules imported to see if they accept the update. And if they don't, we look at the modules that import those. And so on until all past D2 modules that either do accept updates, or we realize we cannot apply this update with HMR. We then take the modules that accept updates and the ones that were modified and others in between them, and we clean them all up and we run them. This way they use the new exports from the modified modules. So we have an API to control how HMR works within the application. This is available in the module.hot object. So if you accept when module.hot is set within a module, then it will, any updates to it or its dependencies will be applied with HMR. If decline is called, then if that module or its dependencies are modified, use hat code push to apply the changes. They can add dispose handlers to clean up the module. These can be used to move DOM elements, clear timers, etc. And they receive a data object that they can add properties to preserve state needed to migrate data to the new version of the module. Then in the new code, you can access that data from module.hot.data to do any work needed to migrate it. So here's an example. So this module has a counter, and we create a div in the body that shows the current counter value. And every second we increase the counter and update the div to have the new value. If this module was replaced as is, every time it was reran, we would end up with an additional element in the body with its own counter and its own interval increasing it. That's not how the app should normally be run. We can use the hat API to configure this. So all this code is within, we check first if module.hot is defined. In production is undefined, which allows the minifier to remove this whole block of code to avoid inflating our bundle size. So we added dispose function. This is one right before the module is replaced. And within this, we clear the interval, remove the DOM element, and preserve the current counter value. Then when the new version of the module is ran, we can restore the counter to the old value. So in the UI, it looks like it kept running. For the apps, fortunately, we don't have to manually decide which module should accept updates or write our own dispose handlers most of the time. Instead, there's one type of module within our apps that's very common and it can be automated for. And these are the UI components. Might be JavaScript files with React components, might be Svelte files with Vue files. For each library, it can be automated in whether it accepts updates and how they're disposed. And since updates bubble up, any module is only used by UI components. For example, we might have a module with utilities or a custom React hook or a Svelte store. Then these modules will also be automatically updated. For all other types of modules, by default, they will be updated with hat code push. And then to fine tune this, you can use the hat API. You might want to also update any Redux reducers, for example, with HMR. So you can use the hat API to configure that. So by default, this works pretty well for most apps. And most apps probably won't need to use the hat API at all. My own apps, I might use in 1 or 2 files at most. So these are the integrations we currently have. For React, we use React Fast Refresh. This is maintained by the core React team and is designed to be more reliable than previous implementations. It's able to update React components and preserve any component state. At the moment, it's enabled by default, but it probably will become opt-in in a later beta. For Svelte, I created the Zoudern melt package. This is a Meteor package for compounding Svelte components. It supports HMR and also has a deeper tracker integration. At the moment, Blaze does not support HMR. There's no technical reason why it couldn't, as far as I know, but no one's taken the time to implement it. So if you're building a package, there's some things you can do to better support HMR. If you're creating a compiler, you might know ways to safely identify which modules can accept updates and how they can be disposed. In that case, you can automatically add the integration to the modules. You can check for file that HMR available to see if a module could be replaced. For other types of packages, we want to provide APIs so a module can dispose of itself. For example, a module might register hooks or do other work that need to be undone for that module to no longer have an effect on the app. It would be nice if we could automate cleaning up for modules that use our package. In most cases, it's not possible, but if a module uses our package within its top level, we can use onRequire hooks to keep track of which module is currently running and to add dispose functions to those modules. We can then use this to keep track of how a module uses our package and then clean up after it. One package that does this is Pure Admin. It keeps track of which module is currently running and so it can clean up. So Pure Admin is a package I created a few years ago that provides a simple UI and then an API that apps and packages can build on top of to create a custom admin dashboard. So here there's 2 common APIs. One is to add a page. Here we're adding a user's page that shows a user's Svelte component when it's shown. And then we also add a user's menu item that shows the user's page we just added. Now this module was replaced as is. Then each time it was ran, you end up with an additional user's menu item. A Pure Admin now keeps track of which module runs, and which module adds each page, and which module adds each menu item. That way when the module is disposed, it automatically removes them for you. And then when your new version module runs, it will create any new pages or menu items using any changes you made to the module. You can try HMR now. It's part of the Meteor 2 beta. So you update your app to the Meteor 2 beta and add the hat module replacement package. For React, this is all you have to do. For Svelte, you can use the Svelte compiler that supports HMR, or you can use the hat API to create your own integrations. Now, it's in beta, so there are some issues. For example, React components and TypeScript files are not automatically updated. But we'll be fixing many of the issues over the coming weeks, and we would appreciate any feedback on any problems you find or ways we could make this better for you. I'd also like to thank Epotech and Florian at Epotech for funding a lot of the initial work on implementing HMR. Any questions? For lathes, I like to experiment with implementing HMR. I'm not sure if I have time for that. I don't know what the plans for Anger. I personally have no plans to implement it at the moment. I'm not sure how difficult at the moment will be to support HMR packages. I think it's mostly implemented. There's just some little bit has to be done left for it to fully work. A module is usually a meter that maps to a JavaScript file or another type of file that's compiled into JavaScript. There's some files in JavaScript that don't end up as a module. You might have files with an kind of compatibility that are not wrapped with a module, but most files are. How did I manage to learn about Meteor internals? A lot of time just reading Meteor code and stepping through the debugger to see what's happening. And other projects that interest me. Right now I'm trying to find ways to improve the server restart time. I'm pretty much focused on performance at the moment and making it so we can iterate faster. But tomorrow I would talk about some tools that I've been working on for debugging Meteor apps. To answer your question, Chris, I spent a lot of time just reading Meteor's code, taking CPU profiles, going through the debugger and stepping through the code. And some I learned by reading various blog posts or other articles that go deeper into the internals too. So to answer your the question about the funding, everything leading up to creating the pull request was funded by Ecotech. That was most of the work on all the research and to figure out how to implement this. And everything after that has been done on my own time, which that helped a lot because it took a lot of time to figure out how to build this in Meteor.